Can dancing molecules heal cartilage damage? So that title certainly of this article got my attention. It says regenerative effects of the molecules might be universal across tissue types. So let's dive into this little science update today. This was published, back in July, but it got some press and was getting kicked around on news outlets for a little bit. But there's a researcher, Dr. Stupp, Samuel Stupp at Northwestern University, and his initial research, what they were really looking at was a very, very, very difficult situation to heal, to repair tissues and reverse paralysis after spinal cord injuries, severe spinal cord injuries. People get a major trauma, and they get a contusion of the spinal cord, injury to the spinal cord. And all the way back to my training as a resident when I was at the Rehab Institute of Michigan in Detroit, they were trying all kinds of different modalities to help people that end up with these really just difficult and challenging injuries to help heal. So what kind of implants or stem cells or things could we put in that environment to help that tissue heal and recover, to give some of those people the ability to move and walk and function again? So as they looked at, this, what they call dancing molecules to repair tissues, they showed the benefit of this and they published this. And what they said is these therapeutic effects of these molecules, worked and helped these spinal cord injuries heal. And then they started to take that concept and say, what other stubborn conditions are out there? And man, in orthopedics, there's nothing more stubborn than cartilage to try to heal. So he said, now we observe the effects in two cell types. They started to look at this in cartilage cells in our joints, as well as neurons in the brain and spinal cord. So you look at two very difficult areas to treat less invasively, and just, again, challenging to heal. So they started to apply these treatments to that because, look, arthritis, as they share in the article, as of 2019, and that was 5 years ago, nearly 530 million people around the globe have osteoarthritis, according to the World Health Organization. And now what we know is for people that are 60, 65 and older, osteoarthritis is the number one reason people will have disability across all conditions. I mean, this is looking at people that have heart disease, diabetes, cancer. And part of the reason is the prevalence of this. So many people can have it. And then the duration of benefit duration of time people may have this could be decades that they're living with arthritis. And all the while, their health is deteriorating, their functionality is deteriorating first, and then their health deteriorates because they just can't stay as mobile and active as they want to with the painful condition of osteoarthritis. So what they're really looking at is, can they take these molecules that they developed in their lab and can they stimulate this healing reparative effect on cartilage? Because if we compare what they're talking about to what I'm doing in my practice every day, which is taking stem cells and platelets, the healing helper cells of the body, and putting them inside a bad knee or a hip or a shoulder to stimulate a reparative process of this cartilage, by first shutting off pain and then stimulating some surface level damage and repair that damage. What they're talking about is really more transformational than that. It is literally reversing that erosion of cartilage and growing new cartilage effectively. So when they started to look at this, of course, we know at the end, the only effective treatment is joint replacement. If somebody's joint gets, to end stage, what we call bone on bone, but we know that's very expensive and very invasive. And then, as he mentioned, current treatments aim to slow disease progression or postpone inevitable joint replacement. They says there's no regenerative options because humans do not have an inherent capacity to regenerate cartilage in adulthood. So we know this as people have studied stem cells. This cartilage is very difficult to heal. Putting stem cells in there can halt the progression, turn off pain, slow down the degeneration, but it cannot completely reverse the damage that's already there. So what they wanted to look at is, can they do that? If they start putting these into animal models, which again, the mice models are used most often, but the interesting stuff in their research is that they're using a sheep model because that cartilage and joint mechanism is more closely related to a human knee joint so they can really understand how this works. What they said is, they're beginning to see, obviously good results with that, to take it into kind of these animal models and see how that does. Because when they induce this change inside the body, what it says is that these nanofibers, these things that they've made in the lab and can implant into these joints, mimic the extracellular matrix of the surrounding tissue. And by matching that, it mimics kind of the motion of the biological molecules and the signaling that our body's constantly doing. And with that signaling being better, it attracts more stem cells into this area to stimulate healing. And so the other thing I liked in this article is they say motion matters, because it does. People that keep moving their joints are going to keep their joints longer. The movement of our joints helps keep the joints healthier longer. When we slow down our activity because of pain, we can't move as much as we want to because of pain. The joint is actually less healthy as a result of that. So everything I'm doing in my practice is applying treatments, using supplementation, using biomechanical correction of joints to offload the bad areas of the joint, to stimulate it with stem cells to heal, to feed the body what it needs nutritionally to heal, to set up your lifestyle, healthy habits, and your body's ability to heal like it does at night for us every night if we're getting enough sleep. But this is something that could be transformationally more powerful, because what they're aiming at is actually the ability to rebuild this lost cartilage through using these molecules, these implanted molecules into the joint. So like I mentioned, what's next for this? Well, his team's currently testing these in sheep models and really trying to understand, kind of all those pathways, because look, you have to be able to control this so it's able to repair the damage back to a point, but not, of course, overrun and create additional cartilage that you wouldn't want in a joint. So it needs to have obviously these stop points. But again, when we look at some of these things that are going on out there, it's exciting for the future, because look, I have plenty of people in my practice that I refer out to get joint replacements. But if we have the ability to do something earlier in the process, slow down the aging of one's joints, and really, truly reverse this arthritic process by regenerating true cartilage in the joint, well, there's nothing like that right now available for the prime time that we can use right now. So this is just some exciting things that plucked from the headlines today to show where things are going directionally in the field of non-surgical, or we'll say minimally surgical, non-invasive surgery that can help joints that are struggling. So, hey, if you like these research and pluck from the headline updates, I like doing these too. It's fun to kind of study what's new, what's coming, what could be. And look, when people see articles like this, they're always messaging my office and saying, hey, is that procedure available? Can we do it? Well, there's a lot of steps that go into this, obviously getting approval. And we know that, from concept like they're talking about to animal trial testing, and then getting over here to actual human testing, and then carrying out results for several years to see how this works without any unintended side effects. I mean, that process can be extremely long. I mean, it could be a decade or longer to get these to the point of understanding, could they really be a treatment of the future. But nonetheless, some cool stuff here, exciting stuff here. And since this isn't ready for the prime time, well, then, of course, everything else you can learn about here on my channel is about non-surgical orthopedics. How can we do less invasive treatments? How can we use platelet stem cells? How can we use the right lifestyle upgrades? How can we use the right biomechanical corrections to give you a healthier, higher functioning joint so you can pain far less than you are now and keep doing the things you love for as long as possible. So if you like this content, please like it. Subscribe to the channel so you can see when I do future updates like this. And if I can help you in any way, of course, always below these videos, I leave a link to my practice. So if it's something that fits what we do, and you're semi-local here in the Southwest region of the U.S., we'd love to see you as a patient and help you in any way we can.